For question one, we are assuming that we want to build a linear regression model of h of x equal to theta 1x plus theta naught. So here we're given with model's parameters theta naught and theta 1. And we are initialized at theta naught equal to 0 and theta 1 equal to 0. We are given with training data set that has two data points, x1 equal to 1, y1 equal to 0, x2 equal to 2, y2 equal to 0. Now here with these points, we are to show two iterations of gradient descent with the learning rate alpha equals 0.25. So firstly, we know that the cost function is basically the mean squared algorithm. So that is given by j of theta 1 comma theta naught is equal to 1 over 2m of sigma I equal to 1 to m of h of xi minus yi whole square. Here, M is the number of training datasets that is given. Here, in our case, we're given with two data points. So M would be considered as 2. So we are also now we have to find two iterations of gradient descent. That means theta naught is equal to negative alpha theta naught minus alpha times 1 over m and sigma I equal to 1 to m of h of xi minus y of I. And here theta 1 is equal to the same thing but times the xi. And since we know that m is just 2, here and we know the other variables, which is here alpha is 0.25, we'll just substitute and we'll, for the iteration 1, I've got theta naught and theta 1 to be 0. And for the iteration, it's the same thing, which is 0 and 0. Here, the learning rate would have no effect on the both of the iterations of the gradient descent. Now, after adding the regularization, we are assuming to add the regularization term theta 1 square to our loss function. Here, we know that the regularization after adding the regularization term to the loss function, this is what we have as our formula. And here we are using lambda is as 0.1 since we are having regularization to be theta 1 squared. So using the formulas of the gradient descent with the regularization, which is for theta 1 and theta naught, for theta naught we're given theta naught minus alpha of 1 over m of sigma. And using this one where we have at the end, we are considering the regularization term, lambda over m theta 1 naught. And we're given with theta naught as 0 and lambda we're taking it as 0.1. Substituting everything, we get 0 and 0. So here we're given with which term would monitor to ensure that the gradient descent works correctly. Here, the regularization cost function would monitor to ensure the gradient descent works correctly. Because we generally know that the regularization cost function is the original loss plus the regularized term. And because of the lack of change in the parameters values, that indicates whether in the learning rate or the data or the model needs adjustments for effective learning. So that's why that is the one that works correctly. Now, coming to question 2, we are considering a trained neural network to classify medical images into either benign or malignant. And here we are given with a network that wrongly classifies 10% of training data, 15% of validation data, and 2% error. So now we are here given and asked to list 5 actions that would improve the network's accuracy. So in my opinion, these are the 5 factors that would tremendously improve the accuracy when considered. So the first one is by increasing the size and diversity of training data set. So the more diversity of training data, the better it is. So we need to have the range of possible images, like all possible images range, in order to get a good training data set to be, to get more accuracy. Second is having a different network architecture. Since we're doing image analysis over here, we are using medical images. So better is to use a different network architecture like a convolutional neural networks, which are very effective for image analysis. Third is using data augmentation techniques. So data augmentation is extremely useful in this case, where we don't need more data, like large number of data, We can just use the existing data set and use the expand the training data set artificially by resizing, reshaping, rotation, and all the data augmentation techniques. And this also improves the network's ability to generalize the model. And the fourth one is fine tuning hyperparameters like the learning rate or the batch size. This also would improve the network's performance. The fifth one is by including feedback techniques in the training process. Like, for example, we know active learning is a good feedback technique. So, by using active learning, it will help better network predictions and also expert accuracy. Now, coming to the second option, which is B, what nonlinear function do we use at the network's output layer? Generally, since this one, a nonlinear function would be a sigmoid function. And also for this case, we are given with a binary classification task where our output would either be in two options. So either benign or malignant. So that's a binary classification task. So common nonlinear function used in this output layer would be a sigmoid function, as mentioned. So sigmoid function is sigmoid of x equal to 1 over 1 plus e power negative x. Here, the negative x is a input value, and that would be in the range between 0 and 1. And that is the probability of one of two classes. So it can be 0, 0.5, 0.8. It's basically the probability that one class would be the right option in between the two classes. And here E is the base of the natural law. Now, coming to question 3, we are assuming that we are building a neural network that classifies color images. So with the height 100 and width to be 100 into either indoor and outdoor classes. So since we are given with the color images, generally color images have 3 channels: red, green, or blue. So that would give us color images would give us 3 channels of the same image. So now our first question is, we need to find we have a one fully connected hidden layer, and we need to show and compute the total number of parameters in the network. So basically, I did draw the architecture of this. So generally, for a fully connected hidden layer, we'll have a hidden layer, and we'll have the inputs and an output layer. So in the input layers, it's basically the height and width given. In our case, we are given with 100 times 100x 100. And since we are given with 3 channels of, since it's a color image, we'll have 3 channels. So we'll consider 100 times 100 times 3 inputs, and which is, in our case, we'll call it as neurons. So we are given with 30,000 neurons as the input. Here in the hidden network, since we don't know how many neurons we're taking, I'm assuming it as n neurons. And now for the output, we know it is either indoor or outdoor. So we can say we have 2 neurons as the output layer, in the output layer. So the total number of parameters would be from the input to hidden plus the hidden to output. So in this case, from input to hidden would be 30,000 times the neurons, the unknown neurons, which is in the hidden network, plus the hidden network, the number of neurons which are in the hidden network, and that gives us from input to hidden. Now we are also considering the parameters from hidden to output, which would be the number of hidden neural networks times the output. For our case, we have 2 neurons, so that would be 2 parameters. So this would be the total number of parameters. Now, option B is to find the dimension of layers output if the convolutional layer with 64 filters and size 3 times 3 with stride 2 and valid padding. So here in a convolution layer, we'll have multiple cells. And here will be, since we're considering size 3 times 3 and we're taking 2 strides, we first need to find the output dimension for each filter. So we're given with the formula that to find the output dimension of each filter is equal to the input dimension minus the filter size over the stride plus 1, which is h minus f over s plus 1, which is the input dimension is 100 minus 3, the filter size, over 2 plus 1. That gives me 49. So now we can say that the output dimension would be 49 times 49. And we're also given with a depth of 64, which is 64 filters. depth is in our case the filters, our final output dimension of this layer would be 49 times 49 times 64. Now, if what is the parameters in this convolutional neural network? It is, since we have 64 filters, each with 3 times 3 size, and we have 3 color channels. So it's not only one image with 64 filters, but 3 filters, 3 images with the same size and number of filters. So which is for R, this R, G, and D will have 3 different dimensions. So that will give us 3 times 3 times 64 times 3, which is 27 times 64, which is 1728. Now, what is the output dimension if we add a 1 times 1 convolutional neural network layer with 16 filters? So basically, if we have 16 layers now, the output dimension would be, since we're only changing the depth, and here we're having the same convolutional layer with the same size, that would give us the same output dimension that we've used in the previous case, which is 49 times 49, and only the depth is changed, so that would be times 16. And I've also given an additional answer over here, which is for parameters, the number of parameters for this 1 times 1 times 16 case. Now, the final question is, imagining a company is developing a deep neural network to classify defective products versus normal products. So my colleague is asking whether we have the classification of 95% accuracy. The colleague is asking if the classifier is actually good enough. So for this case, I would think I would say, and I would recommend to further look at the implications of the remaining 5% error rate, because generally since it can also be one of the safety issues, since we're considering defective products versus normal products. It's always important that we have higher accuracy. Well, 95% accuracy is a good accuracy. More accuracy is always better. So we can look at the database data set and see if there's any case where we are lacking, or we can get better accuracy. So if we can see the data set is if whether it's biased towards one class, then that can potentially affect the accuracy. So maybe try changing the data set, like having a good unbiased data can increase the accuracy, or examining the errors by looking at the confusion matrix, which basically gives the false positive and the false negative, all the positives and negatives of the rates of the errors. So that would give us a good clarity on how our error is distributed, and maybe can also give us an idea on how we can improve the accuracy. And by considering these factors, we can definitely increase and get a better accuracy. So that would be one of my recommendations. Now, my colleagues is asking that he wants to collect 100,000 more samples to improve the accuracy. While that's a good option, that would take 6 months and cost $1 million. So a better option would be always use the existing data and have different images based out of it. So for that, the method is data augmentation. So by using data augmentation techniques, by using the same data set we have, we can change it, tweak it, and artificially use that data in the training data set and get more accuracy. And data augmentation is also useful for this case, particularly because we're considering defective versus normal products. So it's a binary classification. And here we can also fine tune the model, use another architecture, because these methods are, for more cost effective solution and to ultimately improve the model performance, and also will save time. So that would be my recommendations. Thank you.